Welcome to Pepperl+Fuchs Plugged In, where automation professionals can stay in touch with the latest enhancements in sensing, data communication, and control.
Hello, everybody, and welcome to Pepperl+Fuchs Plugged In. Today I have with me Jerry Pacey. Hello, Jerry.
How you doing, Helga? Thanks for having me.
I'm doing okay. Jerry, what are we talking about today?
Contour2D.
Contour2D. That's a cool name, but you got to explain to us what it is, why we need it, what is it good for?
Sure. So I'm glad you like the name. To start, conveyor belt utilization is what we're after with this technology. In a nutshell, it's a system that keeps boxes flowing along a conveyor efficiently. Now, a few things to keep in mind. Box flow, like I just said.
Yep.
The issue of shadows, I'll explain more.
Okay.
Simplicity, and a system with a high level of flexibility.
All right. So 4 things I took down. Belt utilization and flow. What does that mean?
Sure. I think the best way to understand this technology is to imagine this. Let me paint a quick picture. You shop online frequently, right?
I do.
Okay, great. Now imagine your most commonly used online retailer and that you, or our listeners, are one of the many engineers at their largest distribution center. So we're talking miles and miles of conveyor lines, among other automation. It is your job to ensure that this conveyor line is running smoothly, fast, and maybe more importantly, efficiently.
Yep.
Pretty tough job. Millions of boxes are coming down this conveyor line. So it's absolutely imperative that you have an understanding of the stream this conveyor is seeing. Too many boxes or not enough boxes on the belt, the wrong size conveyor for the box traffic, or boxes that are too tall. These are all problems you're faced with. And this Contour2D is the solution.
So simply speaking, box utilization means, or optimizing for box utilization means to keep as much stuff go across the conveyor as possible without causing jams and without having any unnecessary space in between.
That's right. What you just described is efficiency, right?
That's true.
So in these highly automated intralogistic areas, improving the efficiency of the flow of boxes like you described, parcels and goods is absolutely critical. So let's give me an example. Let's say your conveyor belt is 3 feet wide. This Contour2D technology is able to output a percentage used value, informing you of your efficiency. So in this example, if your box passes by the scan area and it's taking up 1.5 feet, easy math, 50% of your belt is being utilized. From our software, you will receive the 50% output value, simply like that. So this kind of data is very valuable. In addition to a belt utilization percentage, this technology can also output flow width, max height, and average height. Even more, all this data from the Contour2D is sent out live in one telegram.
Wow.
Very important.
Wow. So the other keyword that I took down here was shadowing. That I'm not familiar with that. Can you explain what shadowing is?
Sure. I think it's kind of what you think. So we have had direct experience with alternative solutions, and we've listened to end users' feedback, maybe even their complaints. And at the top of everyone's list of issues was this shadows. So let me break that down with what these solutions look like to give you a better perspective on what is implied by this term shadow. So you have your assembly line that has the boxes moving along like we talked about earlier. Generally at some location along the conveyor line, there's a station that has LiDAR sensors installed above, looking down at the belt and boxes. The LiDAR sensors are providing measurement data back to a controller that's nearby this station. And this is where, calculations, evaluations take place, right? Now, of course, since this is a podcast, we're working with audio here. It's a bit cumbersome to explain without a picture. Simply put, the location of the LiDAR sensor looking down at the box, you have blind spots on the sides of the boxes. Blind spots. These
so
blind spots. Go ahead.
If our listeners could see me, I'm drawing the picture almost like a Christmas tree.
Yeah, sure.
And so the box creates that shadow. That's interesting. So why is that critical?
Okay, well, good question. That's a good way to describe it too. So these blind spots are commonly not accounted for in the measurement.
So the box appears bigger in the measurement than it really is.
That's
so
right.
Therefore you're misled.
That's right.
That your utilization is really high or good, where in reality it's low.
That's right. You have an inaccuracy there.
Inaccuracy, yeah.
So it's not commonly accounted for with other solutions measurement data. But with our system, we can account for these blind spots with an accurate output measurement data.
Oh, that's sweet. That's sweet. Now, the other thing, that sounds fairly complex though, but you said simplicity.
I did.
How do those two terms go together?
So,
how can this be simple?
Okay, yeah. So, right, I did say simplicity. And when I speak of simplicity, it's an advantage because we're able to provide all of this, maybe a little bit of complexity, measurement values with simply one LiDAR system. That's what I mean by simplicity. Others maybe utilize 2 or 3.
That means one scanner, one LiDAR scanner mounted above is one component. What else?
So you also have the evaluation unit, which is a system, and I'll talk more about that as well. But with the simplicity, with one LiDAR sensor, our R2000 LiDAR sensor, you obviously, decrease the system price. And from our view, you don't over-engineer the solution. And lastly, when you have one sensor like we're offering, the installation process is a lot more simple.
Yeah, much simpler. One thing, you put it up, you apply power and Ethernet connectivity, and you're done.
One time.
Great. Now, the fourth term that I wrote down was flexibility.
Mm-hmm. So let me explain that. Pretty simple. Lastly, so our software and our integration team are set up to be, what I said, flexible, right? So this means if a new application comes up to utilize the system in a creative way that, look, maybe we haven't thought of, we can play ball. That's what we mean by flexibility. We're not set in with the way that we're promoting it today. We have flexibility there.
Great. So now, Jerry, thanks for explaining what this tech does and why it's needed. Optimization of flow and optimization of throughput. Let's talk about what it looks like.
Okay, yeah. Very simple answer there. So we kind of touched on it. It consists of 2 parts. Our R2000 LiDAR sensor combined with our evaluation unit, which is the brains behind the system. And this eval unit is, of course, connected to the user's control system, receiving all of this output data that we described. Very simple there.
Okay. Can you tell us how a user would set up the solution?
Sure. I'd like to say it's pretty easy. So from the hardware side, if I start there, it's pretty simple. The R2000 LiDAR sensor is mounted centrally above the conveyor belt and scans across the belt width. So this evaluation unit can be mounted in suitable location because the kit comes with 10-meter cables. So you have a lot of flexibility there from the hardware side. In regards to the software, we have a tool that for your PC, it guides you through the simple configuration. And this tool is also able to maintain and monitor the system. We have a step-by-step guide available, and our team is finishing up a pretty cool short tutorial video, which will be posted on the YouTube channel.
Okay, now I'm sure we see the shadowing effect that I so inadequately tried to describe by Christmas tree there as well.
Yeah, if you had a tough time understanding what we mean by shadowing on that video, you'll be able to see it shown visually on the YouTube video.
There was one other question, sorry for coming back to that though.
Yeah, sure.
When you told us that the R2000 LiDAR scanner is mounted above the conveyor belt, how critical is it to find the center of the belt? Is it okay if it's a little to the left or a little to the right? Does that really matter?
No, it doesn't actually, because you have the ability in the software to account for the width of conveyor that you're dealing with and things of that nature. So you have a level of flexibility that you can adjust for specific to your particular application. Of course, there's limitations with the LiDAR and how far I can see.
You can't mount it 5 meters off the conveyor, but you don't have to be ultra precise when you do that.
That's right. You have flexibility there.
Good. So that adds to simplicity yet again. Mm-hmm. Good. Let's talk quickly about the interfacing. What type of systems would the Contour2D typically interface with?
Very short and easy answer there. So all Ethernet capable computers or controllers, because the output is a simple TCP telegram. Very easy.
All right. Anything else I should know before I attempt to summarize what you told us today?
I think we've covered enough to pique interest.
All right. So let me try to summarize, and you correct me where I went wrong.
Okay. Sure.
So the Contour2D is a system that provides precise belt utilization.
That's correct.
It corrects for this box shadowing effect. Please watch our video.
Yeah, that's right.
It's easy to install because there's only 2 components, an R2000 LiDAR scanner and the control unit.
The evaluation unit.
That's evaluation unit.
Mm-hmm.
And the R2000 doesn't have to be mounted with an exceedingly high degree of precision.
That's correct. And one more thing, flexibility. We have the ability to be flexible, because we're set up to, and we understand, look, that the way we're promoting it may not be the exact way another user may use it.
Yep.
We're ready for that.
And I had one more, and that is a simple TCP-based data frame.
That's right. All of that data we're talking about comes in one string.
Excellent.
Mm-hmm.
So now that I have done my job, your job is to give us 5 words or less so that anybody that's listening, essentially the takeaway. What do you want our listeners to take away from our 10-minute conversation?
Yeah. Okay. Well, 5 words. Well, belt utilization can be easy.
Wow, that's great. Belt utilization can be easy.
That works.
I hope we proved to the point that it is simple to do. It's powerful, and we hope that someone out there will find a use and give us a call.
I'm sure they will. Appreciate your time.
Thank you very much, Sherry. And thank you very much for listening, everybody. This was Pepperl+Fuchs Plugged In. Take care. Bye-bye.
Have a good night.
We hope you enjoyed this episode of Pepperl+Fuchs Plugged In. Please subscribe to our channel and never miss hearing about the latest innovations in factory automation.